Yeah, good evening, everyone. I'm audible. Hello. Hello. Yeah, okay. Yeah, okay. I think we shall start the session. So this today's session will be week 10's practice for live coding session. So here we saw the practice program assignments for the week 10. So let's start with this. Yeah, let me share my screen. Yeah, anyone? Could you see my screen? Anyone? Could you see my screen? Hello, am I audible? Anyone could you see my screen? Yeah, okay. Let's start with this. So this week we have this object-oriented programming, object-oriented concepts. Yeah. So the first practice programming assignments is to create a class named student, and we have two attributes, name and the marks. So it will be string and string, and we have two methods. One is a constructor. So this gets these two arguments and assign those values with the corresponding attributes. And we have this function, the method called printinfo. Okay, so let's start the coding part. So create a class using the class keyword. So and the class name student, and here we add our first method, the constructor, that's the init. And every method should have the self as the first argument. So the first argument what we give is the it represents the object itself. So to access the attributes or the methods of the object, we should pass the self as the first parameter as the first argument to every methods. So I'll add self here, and we add the two arguments for the init, that is name and marks. So and we assign these two values to to the attributes of the constructor of the object. So we have completed our name function. So we have assigned the name, the variable name to the attribute name, and the variable marks to the attribute marks. Now we shall create the function print info. It's the method. Okay. The print info does not need any other arguments. You just need to print the name and the student marks separated by a column. So we shall do this simply. New print statement, formatted string, using student's name separated by marks and a column by a column. This is what's mentioned here. The name and the marks separated by a column. Click to print this. So that's all with this question. Shall test this.
रोल नंबर वैसे स्टेटस मिलेगा और एग्जाम में मिलेगा आपको रोल नंबर और Pandas. आपको जो इंजेक्ट जगह में करूँगा ना वो आपको मेरा इंजेक्ट अगर आप नहीं करते तो मैं रात रात को बैठूंगा आपको
There is an indentation here. Let me check the indentation once. Yeah, the whole thing is indented. That's the problem. Okay. Yeah, everything works fine for the public cases, and let's check for the private cases also. Yeah, everything is successful. Anyone, any doubts in this? Everyone's okay?
No, sir, no doubt.
Ah, okay. Let's turn it to the next question. And here we have to create a class named Word, and we have defined the class over here. So it has the word and the POS, that's the part of speech. So they also have implemented the function print info to print that word. And we in this code we have to accept the input from the console and call the print method. So there will be 3 lines of input. We have to ignore the third. So we just have to take 2 lines of input and make the 2 lines will be, in the example you could see the word and the POS. And we have to create the object of class word and call the print info method of it. So just take the inputs here, word. So yeah, just call it W for just now because we are using the word to mention the object. So I just W here, and getting the first line as input, and for the POS the second line. Then we just create the word object of the class word, and as the instructor says, we have to pass the word and the POS for the constructor. And we have to call the print info method for this object. That is so we are calling the print info method for this object that we created. Let's test this. It works well with the public cases and also it passes the private cases. Anyone? Any doubts in this? Is everything okay? Anyone? Yeah, okay. There's no doubts. We just move on to the next question. Yeah. So here we have to create a class named point which has two attributes, that is the x value of the point and the y value of the point. So we need to remember these two equations to find the distance from the point to the origin and slope of the line joining the origin and the point P. So it's given by x, and the distance from the origin is given by x square plus y square, or is below the root. Okay. So let's start this by defining a class name point. And we just have to initialize the init function which has two arguments, that is the attributes x and y, and we just have to assign those attributes to the constructor. Just getting the attributes. So that's our constructor, that's the init function, and we have to implement these methods for this point class. So the first one is the distance from the point origin as a float value. So they are trying saying to find this value. So to implement the square root, you could use the square root function from the math library. Or else you could do power 1 by 2 also. So in this case, I am using this square root function from the math library. So every method should have a self parameter. The self argument should be there, and the distance is calculated as x square plus y square under the root. So here is our square plus y square, and we will not have access to this x because that is the attribute of this self. So we have to write it as self dot x, which accesses the x attribute, self dot y. So this returns the distance from the origin to that point P. And the next method to implement is origin. So it's a Boolean function that returns if a point is coincide with origin or not. So that's simply checking whether the point is 0, 0. So that is the origin. So it's origin. So it should return So just check whether self dot x comma self dot y is equal to 0 comma 0. So you could alternately write this as self dot x equal to 0 and self dot y equal to 0 using an AND connectivity like this. You could also write this as this could also work, but this is kind of an easy approach. You could do both. And now let's define the next function is on x-axis. So if a point is on x-axis, the y coordinate will be 0. So it will be like, let's consider axis. So if the point is on x-axis, so this will be so the y value will be 0. So that's simply checking whether the y value is 0. So this returns true if the y is 0 and false is y is not is equal to 0, which means that's not on the x-axis. And similarly we have on y-axis. So similarly we have to check whether the x coordinate is 0. So if a point lies on the y-axis, the x coordinate will be 0. Like this. So the x coordinate will be 0. And the next function is the quadrant. So the quadrant refers to the quadrant of the axis where the point belongs. So let me draw an axis. So this is the first quadrant, this is the second, and this is the third, this is the fourth quadrant. So it goes anti-clockwise. Okay, so on this quadrant, x is positive and y is also positive. For any point lies in this quadrant, x is negative and y is positive. And for any point lies in this quadrant, x is negative and y is also negative. And for any point lies in this quadrant, x is positive and y is negative. So by checking this, we could say that the point belongs to one of these quadrant. So we should check that whether the number is positive or negative by just comparing it with 0. If x greater than 0, it's positive. Else it's negative. So here it's given that it's only called at the points on not on either of the axis, which means none of the x and y values are 0. So we do not have to consider the case where x is equal to 0 or y is equal to 0. Okay, so we shall just use this case to assume that the x is positive or else it will be negative. So we shall define a function quadrant if x is greater than 0. So if x is greater than 0, it belongs to one of the first or the fourth quadrants. X is positive. So you have to check whether y is positive or not. Y is positive, y is also x is positive, and y is also positive. It will be the first quadrant. Else, if x is positive and y is not positive, that means y is negative, it will be the fourth quadrant. Similarly, if the x is not positive, that means which x is negative, it will be one of these two cases. If x is negative and y is positive, y is positive, it will be second quadrant. Else, it will be the third quadrant, where x is also negative and y is also negative. Yeah. So we find our quadrant. And then we have a slope function. So this is the slope of the line joining the origin at this point. Okay. So this point, the slope can be calculated as y divided by x. So just implement that here. Return y divided by x. That's self dot y divided by self. You should also call this self because x and y are the attributes of the object. Yeah. That's all. Okay, let's run this. And the public test cases are passed. Yeah, and the private test cases also. Anyone doubt in this? Okay. Let's go on to the next one. Yeah. So this problem considers a signal, object signal which has two states, red and green, and this is considered controlled by a threshold, which if the vehicle density is greater than the threshold, it turns into green, or else it turns into red. So we have our class name signal, and as attribute state whether it's red or green, and the value is v, which represents the vehicle density, and the 3t, which represents the threshold. And it has the methods init, sends, and update. Yeah. So we start by defining the class. And we define our init function. And it accepts state b and t. So no, it accepts the t as an argument initially, and we set signal as 0 and signal as red and vehicle density as 0. So we need to accept t as a parameter for init function and set self.state to red and self dot vehicle density, that's v, to 0. And we implement the sense method. So it accepts the vehicle density and update the corresponding attribute. So we just have to accept the argument v and update that. So that's just update this. And we next defined our update method. So this sets the state depending on the current values of the attribute. So the attribute v and t is used to set the state as red and green using this condition. If v is greater than or equal to t, it will be green, or else it will be red if less than t. So we set that update function. We don't have any parameters passed to this method. If self dot v is greater than or equal to self dot t, then we have to set the state as green. Else we have to set the self dot state as red. So that's all the update function. So we shall check this. This. Yeah, the public test cases are passed, and for the private test cases, yeah, it's also okay with the private test cases. Now let's move on to the first problem.
Okay.
Any doubts in that?
No.
Yeah. Yeah. So here we have object, a class called vector, which represents a vector in the 2D space. So with this vector has one end at the origin and another end at the point P. So we are implementing basic operations for this vector like scaling, reflection, and addition. So here we have our attributes as x and y similar to that of the point, but here it represents the vector from the origin to that point. And we have the function, the methods to implement here. So let's start by creating a class vector, and we just add a constructor that's in this function. We accept the x and y and assign them accordingly. Okay, then we implement this print info. It represents the coordinates of the current vector in this form without spaces. We just have to print, not return the string. So we just have to print it. So we have to print in the format that is within this parenthesis x comma self dot y. That's what we have to print. And then there is this scale method. So it accepts an integer s and scale the vector by su. So scaling is simply if the vector is x comma y, and to have to scale, you just must multiply the x value and y value by s and return that vector. So here in the scale function scales the current vector. Did not provide a new vector, not return a new vector, just modify the current vector. That's the current object. So we have to modify the current object. So we have to accept the argument s and change the parameters attributes accordingly. So the x will be equal to self dot x times x, or you could simply do this as using the shorthand operator. And similarly for y, and the reflect about x-axis. So reflecting. So for reflection, to reflect about y-axis, we have to negate the x value, and similarly for to reflect about x-axis, we have to negate the y value. That's all. So we shall implement this. That's all. We have negated the y value to reflect about the x-axis. That's minus y. And similarly, we have to reflect about y, we have to negate the x-axis. X value. Yeah. And to add two vectors, so for this method, we have to accept another vector as an argument and return the sum of the current vector and this argument. So we also should return an object of the type vector. Okay, so let's do that. So we create a function add, creating method add, and accepting self and another vector. Let's call it v. And now for the result, we have to create a new vector. For that, we just store the values there. So x is equal to, so this x will be the x of the result and vector. So x is equal to self dot x plus this new vector v dot x. So the x value of the new vector and the current vector will be the new x, and the y will be self dot y plus v dot y. And we should return this as a new vector. So we shall return this as new vector whose x is x and y is y. That's all. We'll also write this in a single line like this. Like just substitute this here. Similarly, so this here, This could also test this for the public cases. Yeah, and for the private cases. Any doubts in this? Yeah.
What if the vector is like some variable, right? So we have not defined any vector variable.
So you are asking this vector, this one.
Yes.
So this is the name of the class that we have just defined here. So this is how we call our constructor. So we just initialize the object as we did in this previous exercise. You could see that we created a new object word using the by calling the constructor of the class. So this calls the init function for the class. So this word of w comma pos calls this init function. So this function is called, and the word is given as the word, and the pos is given as the word, and this is executed in this word. Similarly, when we create this a new vector, we have to create a new vector that is the object of the class vector. We have to do it in this format where we use the class name and pass the parameters that the init function has, x and y. That's what we have passed here, the x value and the y value.
Okay. Okay.
Yeah. Okay. So, and the next 5 problems, so these don't have test cases. This is just for how to use this Matplotlib library to plot various equations and functions and other data and other things. This is used to create various different plots. So we shall start this section. So these 5 problems. These are how to use the Matplotlib library. So we shall start by this. So I am here using a Google Colab notebook to run this code. If you are running now want to run Matplotlib in your local system, you have to install this NumPy and Matplotlib using the pip or according to your current Pandas environment or any other environment. You have to follow the instructions for installing that package in that environment. So in Colab, it's all the NumPy and Matplotlib are already installed. So you have to just import this and NumPy. So usually we import a NumPy as NP as a shorthand, and the matplotlib.pyplot, and this is a submodule of the Matplotlib. This is what we use to create our plots, and we call this PLT as a shorthand. So we shall import this. Yeah, and this is the NumPy, a module from this file, and this is matplotlib.pyplot. It's model from this file. So the NumPy and the NumPy library is mostly used for mathematical operations, performing mathematical operations on arrays. So arrays is like a list-like structure, a multi-dimensional structure, but the values are of the same type. So an array has 2 things: the values, that's a list of items, and it has a shape and a data type. So all the elements in the array is of a similar data type, like float and integer, etc. So these are few methods that we use to initialize the array, the NumPy arrays. And there is also some methods that we use to create random elements. Like there is a module called random in Python that generates random numbers. Similarly, there is also a submodule called numpy.random, which we use to create random integers or some numbers. So there are different random functions are also there in NumPy. You could see that in the NumPy documentation. There are different functions. Listen here, these are the list of function rand it. So for this this exercise, we only need to use this random integers randin function. We generate random integers from a given range, that's low to high, excluding high. So if you call this like 0 to 7, it will generate only random numbers from 0 to 6, not including 7. Yeah, we shall look at these functions. So this is this function. So we call this n.0, and this is the shape of the this argument is the shape of the given array. So if you print this, so this is will be consisting of 10 rows and 5 columns, fully initialized with zeros. So it's like a matrix. So if you put just 10, it will be a list of 10 zeros. That's in the format of numpy.ndarray. ND array refers to n-dimensional array structure, which is basic structure it's used to represent matrices and higher dimensional matrices in the NumPy. So here you have the shape and here you have the data type. So you have to pass the data type as like this. So this is the 64-bit integer data type. By default, it will be float. If you leave out this argument, it will be float. And similarly, for ones, it will be all ones. And this is a range. It's like the range function in Python that creates a list of that's the array of numbers from 1 to 20 using the step 1. See that? Not including 20, like the normal range function. You could also use a step size of 2 as in the range function in Python. By default, it will be 1. And there is this linspace function. This creates within this range, that is from 0 to 10, creates 50 points that are equally spaced between them. So for example, so you have this points 0 and 10, and you divide this into 50 equal halves. So this will be some point like 1 point something and some points like that. So that points will be so let's check this out. So it will take 50 points that are equally spaced between 0 and 10. And if you take 10 points, it will give you 10 points. So there are 10 points that are equally spaced between 0 and 10. So it's including 10. Yes. So if you use 11 points, one of each points, including 0, 1, 2. So this will be 11 points equally spaced from 0 to 10. So this will be a quite handy function. And this is randint. So for randint, you have to give a range like 0 to 7. So it will give random numbers between 0 and 6. And we have also have to mention the shape. That's the next argument. As I want like I have to have 10 random numbers. So it will be 10 random numbers from 0 to 6, not including 7. So if you want to reproduce the results, because like each time when you run this randint, it will be every time you will get a different random value. So if you want to make that the random function generates the same thing randomly, you have to add some kind of seed here using np.random.seed. For this value of 1, it creates a set of random numbers. Let's generate 10 random numbers. Yeah. And if you run this again, it will produce the same 10 random numbers. So if you want to change this set of random numbers, you could change the seed. When I change the seed, the random numbers changed. But if I run this again, it will be the same random number that we get for the seed. And the benefit of using this ND array is that we could do arithmetical, logical, and other mathematical operations for this array of values, like we do for individual values. Like when we add two numbers x and y, we get a result. But if we have two NumPy ND arrays as x and y, it will add the corresponding values like the 0th index and the 0th index of x and y, and the 1 and 1 of x and y, and use that result as the a here. Similarly, you could write any mathematical arithmetical operations like this: power, subtraction, division, multiplication, anything. So it do performs that operations for their respective elements and returns an NumPy array accordingly. And similarly, we have this logical functions. It would return an array of true and falses, and you could there are specialized vectorized functions that are defined in NumPy that's similar to the normal mathematical operations that we use, like sine, cos, tan, exponential function, the logarithm. Everything is also have the vectorized functions defined in NumPy. If you want to call the vectorized implementation of the mathematical function, you could just call the NumPy dot the mathematical function's name and call it over a vector. That is the NumPy array A. So we shall just check this. So this you get. Yeah. So we have two arrays. That's A 0 to 9 and B is 5 to 14. And we just print A and B. This is the A and this is B. And then we have A plus B. So you can see here that this is the sum of the first element and the first element of A and B here, and the sum of the second element and the second element here. Similarly, for every value. So this gives the A plus B. And this is equation like 2 into A minus B. You could also verify this. It's also similar to corresponding values and it's written. And similarly, A power 1 by B. This. And we have evaluated the logical operations. A greater than B. So A greater than B is false for every values. For any value here, if it's not false, we will have the corresponding value as true here. And similarly, we have checked another logical equation like b minus a equal to 5. Since we have b minus a equal to 5 for every thing, every corresponding values, we have true either throughout the NumPy array. And you could also evaluate this kind of mathematical functions using NumPy's own mathematical function, like NumPy exponential, that's here. And we also have the variable constant pi in NumPy that we could use to multiply with the array. This would be quite handy. Okay, and the basic plotting. So we have imported the matplotlib.pyplot as plot. So the basic plotting routine will be like we have to have a set of x and y values like here. Yeah. So consider this plot. So we have certain points 1, 1, 2, 2, 3, 2, 4, 3, and 5, 2. So to plot this graph, we need the values x and y. Here it's 1, 1, 2, 2, 3, 2, 4, 3, and 5. So if you have this as x and this as y, you could pass this to plot dot plot. So the plot function in the PLT, that is pyplot, could create different plots, different plots of different styles. By default, it creates a line plot like this by default. And there is another type of plot called scatter plot. So this is if you have points like this, that is 1, 1, 2, 2, 3, 3, and some other points. It just makes a dot in that point. So this will be like scatter plot. So the 1, 1, just you have the dots like this. Just have the dots in the scatter plot. And there's another kind of plot called bar plot. So you have this x and y values. For the x value, the y value represents the height of this bar. And for every x value, the y value will be the height of the bar. For example, if 1, 1 is there, so it will be like a square. And if 1, 2, 2, be like a 2, the 2 will be of height 2. So this will be of height 2. Yes, 1 and it's 2, and it's 3, 4 will be like this. And here it's 3 and the height is 4. So this will be the bar. So we have this free function. This is for general plots, and for scatter plot we have plot dot scatter. We also pass x and y here, and plot dot bar. So generally we plot using this plot function or any one of this function, and call the plot.show function to display that plot into the notebook. So we shall start with this. So here we have this whole lot of function. We have to plot in a separate graph, each on the separate graph. So we start this. Okay, so let's define the x values. So we shall take any range of values for x. So for this example, we take range of values, that's NumPy.len space from 0 to 10. I take 100 values, that's 100 equally spaced points between 0 and 10 as the x. So we have these points like this, like 0 and 10. We have 100 points. So for each point, if we evaluate this function, even here, you could get the y value for the corresponding x value. So you could get the y and x, then we start the plot. So let's have y equal to 3x, that's 3 times x plus, so it's minus 4. And we just have to plot this, plot, plot x comma y, and call the plot.show. For this we have our plot. So it's a straight line, equation of a straight line, and the straight line is plotted here. And for our next equation, just call that y2, and that is x square plus 2 times x to minus 15. And we call plot dot plot x comma y2 and plot dot show. So now we get two plots, and this is a quadratic equation as you see here. So it will be a little bit curved like that. So we have to do this for every equations. So just we could use a loop here. So I'll just use a list called y's and take this here, and every other equations consecutively, and I use a loop. So for all that, I'll just put that. So we just add the other equations here. So we have this 5 times x minus 1 times x minus 2 times x minus 3. So it will be a cubic equation as you see the 3x factors. And the next will be e power x. For that, we have exponential function defined in the NumPy itself. So we just call that of x. And the next one, the log. So for the log, we have the log function defined in NumPy. We got log of x. And similarly for sine also. Yes. So we just got all of this. So you can see this is the first straight line, this is the quadratic equation, this is the cubic, and this is the exponential equation, and this is the log, and this is the sine. You can see everything's okay with this problem. That's the PPA 6. Is everything okay? Yeah, no doubts. Then we shall move on to the next one. So this is how we do individual plots. So there is a warning here because we have the range 0 including here, and the log for 0 is not defined. So that's what it is. So you just ignore that. Okay. Now we have to plot these two functions on the same graph. So on the same graph, to do that, we should call the plot functions before calling the show. So if you call the two plot function before calling the show, the two plots will be displayed in the same plot. So we shall check it. So we take a range of x equal to then space 0, 10, and I take 100 values, and I'll plot sine of x using NumPy's sine function, and plot cos of x using NumPy's cos function, and I just display it. Let's show. If I do that, I will get this both function, that is a sine colored blue here, and the cos function colored in orange here. See that the sine and the cos, the same plot. Any doubts here? So if you call show after one of the plots, it will be on two separate plots. The sign will be there and the cost will be here. If you don't call show, both will be on the same plots. You can add as many as equations here in the same plot. Yeah. And for the PPA8, we have the CSV file. So it has the contents like this, the math and the physics course. So I just run this to create that course.csv file. We have the CSV file here. Okay. So we have to do with the x-axis on the physics code, have scatter plot. So a plot like this one, a plot like this, using the plot.scatter with the x-axis of the mathematics course and the physics course on the y-axis. So first we load this CSV. So for that, for green CSV we have, as shown in the previous week, we can use the Pandas library to load the CSV file. Using like this, we have to import the Pandas library. We usually import it as PD as a shorthand. Even Colab recommends that. And we use the data frame to read the data frame to read the CSV file using pd.read CSV function. We have to show the file name. And we can use the df.get function to print the sample. We have the max and the physics values. So we could access the max and the physics values by indexing simply. So to create a plot, simply a scatter plot. So it's plot.scatter. So on x-axis we have to give the max scores. So it's like will be like to get the max scores, we could just index the max. And similarly for the y values, we could index the physics. And just plot.show. So you could see the points plotted here. So it connects the points from this math. So this is the math marks in the x-axis, the physics marks in the y-axis. So do you observe anything? This means you could see that there is a correlation between the maths and the physics scores here. Even though there are some outliers here, most of the thing max mark is proportional to the physics mark. That is, the physics marks is proportional to the max mark. So it says that mostly students with the more math marks are also good at physics. But even though there are some exceptions like the outliers, that's all points are low and below. But on average, it's true like that. We make an assumption like that. Is it okay? Any doubts in this? Yeah. Let's move on to the next one. So here we have this. So we have to perform this experiment. We should throw a standard unbiased 6-sided dice 10 times. So they have given the values for n here. We have to do this experiment for these values of n. So we'll just start with the value of n equal to 10. Okay. So throw a standard unbiased times 6-sided dice n times. So this is when you throw a dice, it gives a random number between 1 to 6. So that's exactly what we can do using the random dot rand int function. So So to get that n times, we could use like, so this is called x and numpy dot random dot rand int. So it will be number from 0 to 6. So we have the low and high, but excluding high. So we use 0, 7. So it will be excluding 7. We need to generate n values. So that is n. Okay, we got our x. We have to get the frequency of occurrence of the numbers. So we'll just create a dictionary called freaks. That's frequencies. Just initialize for every numbers from 0 to, so well, this is, we have to create from 1 to 6, right? Yeah, it's 1 to 6, including 1 and excluding 7. Okay, for frequency, that's for I in frequencies, I in range of 1, 6, 1, 7. For all the values, we just initialize first. Freaks us 0, that's freaks of I is equal to 0 for every values from 1 to 3 to 6. And then we shall count that. Next, just update and 1 by counting the values next. And now we will have the frequencies that contains the number of occurrences of each number. So we will just print text here. Also print frequencies. And what we have to do next? Just check this. We have the numbers and we have the frequencies. So there is no 4 here, that is the frequency 0. And 3 occurs 4 times, that is 1 and 2 and 3 and 4. Similarly for all numbers. And now that we have to convert these frequencies to probabilities. So to do that, what we have to do? Just divide this. So it's like the formula for probability. That's probability of an event. P of A is given by number of occurrences of that event by the number of size of the sample space. That is the sample space, size of the sample space. So in our case, the sample space is x. X is our sample space. We have n samples, that is 10 samples in the beginning. So the size will be 10. So that's the size of x. So we have to just divide the number of occurrences of A, that's the frequencies, by the size of the sample space to get the probabilities. Yeah. To do that, we have props equal to, so we just run a loop. Props of I will be equal to x of I divided by x dot size. So we have to initialize props first. As a dictionary. So we just print props. You see that. So to reproduce the result, we shall also add an C here, so that we don't get different numbers every time we run this. Okay. We have 3 and this is 3 by 10, which is 0.3. So there are totally 10 samples here. So size of the sample space will be 10. So we have 0.3 and 0.2 and 0.0 and accordingly. we have the probabilities. Now we have to represent the probabilities in the form of bar plot. So you have to use the bar dot plot for this purpose. So we shall also do that. So that's done by plot dot plot. So it's bar. What will be the x and y values? So the x values will be this key, and the y values with these values. So we will just use props dot keys and props dot values as y value. So here will be our plot. So now you see that the frequencies differ here. So the variation will be much more when we compare like this. So we just run this experiment with different values of it. So we just run now this with 100. You could see that the differences on a large scale is compared to less than before. Thus, in the previous case, we don't even have some values for some numbers. Yeah. You could see that number of sample gets increasing. I just had another 0, that's 1000. And this is 1000 random values. That's 1000 random rolling of that dice. And you could see the differences is much lesser. But you could see that the differences is you could see visible differences here, but on a scale, it's not much. And now, so this getting bigger, so we just turn off this print, and now I repeat the experiment. See, it goes closer. So you can see the probability is getting really closer here. And finally, this many zeros. You could see that it's almost equal to 66, 0.66, 7269. So the range will be decreasing. So the probabilities will be, as we take more samples, it will be getting more equal. The probabilities will be. You could see for 10, the difference between the probabilities is much larger. See, it's 3, 2, and 0. The difference between the probabilities are much larger. But for this number, as many zeros goes on, the difference between the probabilities will be reduced. Staying time, we have a lot more values here. It's taking much time. Stop this. And now it's better. You could see that the difference between the probabilities is much less here. That's the observation we make. As the number of samples increase, the difference between the probability decreases, and it's just random. Okay. So now this is a different question. So you have to plot a circle of this given equation with the radius 5 using scatter plot. So we have to need the points of the circle before doing this. So we have our equation x square plus y square equal to r square, where r is the radius, and it's given here it's equal to 5. So we have to plot a circle, radius 5. So it will be here 5, this 5, this 5, 5. So we have to plot a circle, a really good circle, passing this through these points like this using scatter plot. So we need the points here. So these points and these points. So we need the x value and the y value for all these points here. So how can we take that? So one approach will be like this. So just sample equal points here in the x-axis as we do in the previous problems, like from -5 to 5. That's minus r to r, minus r to r. For sample using linspace and get the corresponding y values. Like, so what will be the y value according to this equation? It will be plus or minus square root of r square minus x square. Yeah. So there will be two values for our x value. There will be a positive value and a negative value. So you have to plot the positive and the negative, the same plot. So you could do that. So we have to use a scatter plot. So we shall do this now. Okay. So you just create x values. That's np dot space minus. So this is first define r is equal to 5. Space is equal to from minus r to r. So we shall get 100 points here. And y will be, so we have two sets of y value. Okay, that's just the positive y values. What will be dot square root of r square minus x square. This will be positive values. And for the negative values, we have negative. So plot this, just plot dot scatter x comma y plus. For the negative values, we just have to negate this. And the plot dot scatter on the x and minus y plus. And we just show that you could see that here in these places the density of the points is smaller, and here it's too close in the center. But on the edges the density reduces. Why this happens? So we are equally sampling points from this x-axis, but the corresponding points are not equally spaced in this circle. So if you are using this kind of approach, this area will be scarce and this area will be dense. So could we improve this by equally spacing the points over the circle? Yeah, we could. So for that, we could have another kind of approach, like parallel axis. So this is a circle, right? Yeah, circle. We have a circle here. A circle. Okay, let's consider this as a circle. So this angle will be in radians. The angle that the circle covers will be 2 pi radians. So if we first sample points in equally angles, it will be equally spaced along this circle. So if the difference between the points, the angle of the points is equal, the points will be equally spaced in this circle. So we shall create that one. So the angle will be from 0 to 2 pi. So we just first create equally spaced angles for the circle. And then we have to find the x and y value for that point in the circle that is making an angle theta, some theta. Any doubts still now?
No.
Yeah. So how shall we do that? So considering this as a triangle and this is a theta, we could get this y value as the radius, that is the hypotenuse, should be r, and the y value will be r times sine of this theta, and the x value will be r times, that's the hypotenuse, times the cos of this theta. So this is simply representing as the point and the polar coordinates using r and theta, and we converting them into the Cartesian coordinates, that's x and y. So we sample the points equally along the circle using this angle 0 to 2 pi, and then we make equally spaced points and plot them. So how we could do that? We have the r is 5, radius is 5. So we just now take theta will be in p dot length space from 0 to 2 pi, 2 times NumPy dot pi, and we just take out 100 points theta. Yeah. And to get the x values, you just need r times NumPy dot sine of cos of theta, and for y values r times NumPy dot sine of theta. And we shall plot this. Scatter of x comma y. Sure. You could see that every points are equally spaced along the circle. You could try improving the number of points. Would that make a difference here? Let's check this out. There is the more number of points required to make this complete circle, but that's also not equally spaced because it's more equally dense here and it's sparse here. But if you do this, you could make 200. Even this is okay here, but 200. So there is still this sparsity problem. So that's how we sample the space in equal intervals. So you could create a smooth circle like this. I think 300 will be enough to make the smooth circle. Yeah. This is any doubts?
No, sir. Okay.
Yeah. And thank you. We shall end this session. Thank you.